So in this video, I'd like to take a look at an I-beam example. An I-beam is a composite object with three different rectangles. So that's rectangle 1, 2, and 3. We can use the familiar area moment of inertia formula for rectangle 2 because it sits right here on this neutral axis. But rectangles 1 and 3, they're away from this neutral axis. So for this problem, we'll need to introduce the parallel axis theorem. Okay, so let's get started. The formula, so Ix, that's about this x-axis here, equals 1 over 12 times by the base times by the height cubed. So this portion of the formula, this portion here, that relates to rectangle 2. Okay, because that's sitting here in the neutral axis. But for rectangles 1 and 3, we're going to use the regular formula, 1 over 12 base height cubed, but we're going to introduce the parallel axis theorem, which is AD squared. Okay, so AD squared, what's that referring to? So that's area, A stands for area, so that'll be this area here, either rectangle 3 or rectangle 1, doesn't matter which one. And this D here refers to the distance from this neutral axis to the centroid of that rectangle. That's D. Okay. So note how both of these rectangles, rectangle 1 and 3, are the same, and they're equidistant to this neutral axis. So we can just times this by 2, can't we? Times that by 2 because they're the same. Okay, so similarly, this part of the equation is for rectangles 1 and rectangles 3. Hopefully that makes sense. So let's keep going. 1 over 12 times by the base of rectangle 2, which is 75, times by the height of rectangle 2, which is 600 cubed. Okay, and let's do the parallel axis theorem component. So that's 1 over 12 times by the base of rectangle 3, which is 300, times by its height, 75 cubed, plus the area of rectangle 3, which is 75 times by 300. And now we need to times the distance from the neutral axis. So let's work that out quickly. That there to the edge, that's going to be 300. Okay, and what's this distance here from the edge to the centroid? That's going to be 75 upon 2, isn't it? So let's add that on. So that's 300 plus 75 divided by 2. And this is squared. Okay, so don't forget that. Okay, so we're going to times this whole thing by 2, aren't we? That's because we have 2 of these rectangles, 1 and 3. So it didn't matter that I chose rectangle 3 for this distance, because they're the same. I could have easily just done rectangle 1. And so the answer, the solution for this problem is 6.5 times 10 to the power of 9 millimeters to the 4th.